Welcome to the Explainer. You know, patterns are literally everywhere, but a lot of them have these rules that are kind of hidden just beneath the surface. So today, we're going to crack the code on them. We'll start with a simple puzzle that actually uncovers a pretty powerful mathematical secret.
All right, so let's jump right in with a classic brain teaser. And trust me, it sounds super simple at first, but you'll see it gets complicated pretty fast.
So think about it for a sec. Your first instinct might be to just multiply some numbers, right? But how do you do that without accidentally counting the same handshake twice or missing some completely? The real key here, the secret, isn't just about multiplication. It's about finding the underlying pattern. Okay, so to figure this out, let's not try to solve for 25 people right away. Let's start small and see what happens. If you've got 2 people, it's easy, right? Just one handshake. Now a third person walks in. They have to shake hands with the first 2 people, so that's 2 new handshakes, bringing our total to 3. Okay, now a fourth person comes in. They add 3 more handshakes, so now we're at 6. See what's happening? We're building a sequence of numbers, 1, 3, 6, 10, and it just keeps going. And that's the whole game right there. What is the rule for this sequence? Because if we can figure that out, we can solve for 25 people or 100 people without having to draw a gazillion lines between dots.
All right, so let's start our search for this rule by looking at the simplest kind of pattern out there. It's something called an arithmetic sequence. The easiest way to think about this is to picture a staircase. An arithmetic sequence is like a staircase where every single step is the exact same height. You go up by the same amount every single time. That constant, steady rhythm is what makes it an arithmetic, or what some people call a linear sequence.
And you know what's cool? The test for this is super simple. All you have to do is look at the numbers in your pattern and find the difference between each one and the next. If that difference, that step up, is the same every single time, then boom, you found your rule. You're dealing with a simple arithmetic pattern. Okay, so let's try this out on our handshake numbers. Let's see. To get from our first number, 1, to our second number, 3, we add 2. Okay. Now to get from 3 to 6, we add 3. And from 6 to 10, we add 4. Right away, you can see the problem. The differences are not constant. It's not plus 2 plus 2 plus 2, it's plus 2, then plus 3, then plus 4. So our handshake puzzle doesn't follow this simple rule. The steps on our staircase are actually getting bigger each time we take one. But that's okay. It just means our pattern has a hidden layer we need to uncover.
So, the first layer of differences didn't work. But what if we go one level deeper? I mean, what if we look for a pattern not in the original numbers, but in the differences we just found?
Okay, check this out. We already figured out that the first differences were plus 2, plus 3, and plus 4. Now, let's find the difference between those numbers. The difference between 2 and 3, it's 1. The difference between 3 and 4, it's also 1. Look at that. We found it. One layer down, a constant value finally pops up. And that's it. That's the aha moment. The constant value is 1. So the pattern wasn't on the surface at all. It was hiding one level deeper. This is the big clue we've been looking for. It tells us the sequence isn't random. Not at all. It just follows a more interesting, more complex rule.
And yeah, there's a name for this. It's called a quadratic sequence. And that's the key idea. When the second difference is constant, not the first, it means the pattern's growth isn't a nice straight line. It's actually a curve. It's accelerating. So let's just put these two side by side to make it super clear. Think of an arithmetic sequence like, I don't know, getting the exact same $5 raise every single year. It's steady, it's predictable, it's a straight line. But a quadratic sequence? That's more like a viral video. The number of new views you get each hour is itself getting bigger. That's accelerated growth, and that's exactly what we're seeing with our handshake problem.
Okay, so now that we know what kind of pattern we're dealing with, a quadratic one, we can finally pull out the right tool for the job. We can crack this code and solve our puzzle once and for all. And here it is, this beautiful, elegant little formula. It lets us calculate the total number of connections for any number of items, which we just call n. So, no more counting. Now we can calculate. So let's go back to our original problem, 25 people. We just plugged 25 in for n, so that's 25 times 25 minus 1, which is 24. 25 times 24 is 600. Then we just divide that by 2, and just like that, the answer appears. No counting, no drawing lines, no guessing. Just the power of understanding the pattern. And there you have it. 300 handshakes. The puzzle is officially solved. And we didn't do it with brute force. We did it by finding that hidden quadratic pattern.
But look, this is way bigger than just a fun brain teaser about handshakes. This whole method of digging deeper, of finding hidden patterns, it's like a key that unlocks how so many things work all around us. You'll see it in nature, you'll see it in technology, it's everywhere.
For example, a simple arithmetic sequence, that's like a taximeter, right? It just clicks up by the same amount for every mile you go. Simple, steady, predictable. But a quadratic sequence? That describes something more complex. Think about stadium seating. As the rows go up and get wider, each new row doesn't just add a few seats, it adds more seats than the one before it. If you understand that pattern, you can predict the total number of seats in the whole stadium. It works for taxi fares, and it works for sports fans.
So you see, the real takeaway here isn't just about handshakes or stadiums. It's about the method. It's about the power of looking for a pattern inside of another pattern. So the next time you run into a problem that seems really complex, just ask yourself, okay, if the rule isn't obvious on the surface, what might be hiding just one level deeper, waiting for me to find it? Thanks for watching.